With Fuzzball, we're building the future of performance-intensive computing. Workflow orchestration is a core capability of Fuzzball, with a custom workflow definition system that's built for high-performance computing. Each job in a Fuzzball workflow is allocated dedicated computational resources and can run in a customized environment specific to that job. Fuzzball supports a modern container-first approach to performance computing. It's capable of traditional command-line-driven batch computing, interactive web-based VDI, and even API-driven orchestration as part of your existing or future automation infrastructure. The Fuzzball web interface provides a single pane of glass for making full use of your compute resources. Here, you can monitor and review the status of your workflows, retrieve log output, and even get immediate access to an interactive terminal alongside a running compute job. You can construct new workflows from scratch using the visual workflow editor, or import an existing workflow from a file. You can also manage secrets, members of your shared accounts, and persistent volumes. Administrators can use the web interface to define shared accounts, manage user access, define organization-wide shared secrets, and to define storage classes. Fuzzball users belong to one or more Fuzzball accounts. These accounts allow Fuzzball users to easily collaborate on workflows and to access shared storage. A Fuzzball workflow manages all the necessary activities of your workload. It creates and attaches storage volumes, it manages data ingress and egress, it downloads and prepares container images, and it runs your compute jobs in parallel and in order, according to their dependency requirements and the resources available. Fuzzball compute jobs can use both ephemeral and persistent storage by requesting a volume using an existing storage class. These volumes are then attached to the file system of your compute jobs. Fuzzball manages context-aware secrets for use in your Fuzzball workflows. Secrets can be defined for the entire organization, shared with members of a group account, or set individually by a user. And defined secrets can then be used to fetch data from S3, to download data from a website, to pull a container from a registry, or just as an environment variable within a job. Fuzzball is just as accessible from the command line as it is via its web interface. And because all access to Fuzzball is API-driven, you can run the CLI from anywhere, no SSH required. Fuzzball is developed API first, and both the command line and web interfaces communicate with Fuzzball using a documented, customer-accessible API. For example, you can use a Python SDK to access Fuzzball via its OpenAPI endpoint to build custom automations and integrations with any Fuzzball process. You can deploy Fuzzball Orchestrate into your existing Kubernetes environment using our custom Kubernetes operator. You define a Fuzzball object to automatically create and configure a fully functional instance of Fuzzball Orchestrate, and adjust that definition later to make real-time changes to your deployment over its lifetime. Fuzzball Orchestrate runs on Kubernetes, but our custom container runtime substrate is optimized for performance-intensive work. Compute jobs run outside of the Kubernetes cluster in optimized CIF container images, ensuring effectively bare metal performance while maintaining the flexibility, portability, and reproducibility of a modern container-first architecture. Fuzzball Substrate can be deployed on Enterprise Linux with Ascender or other industry-standard tools, and it can also be provisioned using Werewolf as part of an integrated compute cluster environment.